Welcome to the Science Sunday today that I've put together on exploring colored shadows. And this is an activity I actually got inspired from based on a exhibit at the Exploratorium in San Francisco. Just a really fun place to just play with science all day long if you ever get the opportunity. But they have a really cool exhibit called Colored Shadows. And so this activity kind of replicates that since they're really not open to the public right now and it's kind of far away. So you can do this at home, you can do it in your virtual classroom, and it's a lot of fun. So the first thing we want to start with is actually just what are we even talking about? And so I've made a little video. I recorded it at night so you kind of get the full effect without too much light in the way. And I'm going to play it real quick so we can all just see what this phenomena is, this thing that can happen out in nature. In this case, it was in my house, and it kind of makes us think. We notice something a little bit unusual, and it maybe will create you to think of some questions of things that you're wondering. So I'm going to play it real quick to show you what it is. And then we're going to go into how can you recreate this and explore yourself and find out what's happening with these colored shadows.
All right, so I've got three lights being pointed at my cabinet wall here. There's a red, a blue, and a green light. And what I'm going to do is I have an object here. I've actually got a pencil. And I'm going to hold it up in front of my lights, and I'm going to look behind it and observe what kind of shadow it makes on the wall. So my experience when I'm outside is that when the sun's out and it's maybe directly overhead, I get a shadow on the ground, whether it's me or a tree or a car, and the shadow is usually really dark, like a black or a dark gray. So what I'm going to look for is the shadow behind this pencil. So here's my pencil. I'm going to hold it up in the light, and behind the pencil I see three shadows, and if I move the pencil closer, the shadows get closer together, and if I move it farther back, they get farther away. But I notice that the three shadows I see are actually different colors. So I see a yellow shadow, a light bluish, like a teal color shadow, and a pink or a magenta colored shadow. So it's really interesting because my experience being outside is, some kind of dark colored shadow. But when my light source is not a white light, I'm actually able to make colored shadows, and the colors are different than the lights that are being projected onto my screen. And if I move it in closer, I notice that I even get a green color in there. And a blue, and it's about all I can see when I kind of get them really close together. So I see about 5 different colors in the shadow of this pencil. So this is a phenomenon known as colored shadows.
The colored shadows is something you can recreate at home. And so I want to show you actually how to set this up so that you can design your own experiment with this and see what you can find out from it. And then we're going to go into actually what's happening so you can explain this to your friends and your family as you're showing them your colored shadows. So what you need for this is actually the 3 different colored lights. And I used these little finger lights. I got them at a craft store. You can get them online. They came with like a white color as well, but you don't need the white one. You need red, green, and blue. Okay, so those are the 3 colors, and it's very important that you start with these 3 colors. You could also, if you have different colored light bulbs in red, green, and blue, you could do it that way, or maybe making some filters out of like plastic wrap that's colored. There's a number of ways, but this for me was the easiest thing. You also need some kind of white surface to project on so that it's not interfering with your colors. So a wall or a curtain or even a piece of paper will work just fine. And then you need something that is going to create a shadow. So I used a pencil, but if you're especially maybe projecting on a wall, you can maybe have a volunteer who could make some shapes and you know, different things and see what happens to their shadows, or you can just find an object like I did. So I'm going to show you how to set this up so you can try it. So I've got my colored lights, and for the purposes of demonstrating this to you, I put them all on one board, so I'm not trying to all hold them. But when I recorded my video, they were just set on a table, a little bit spaced apart so you can get them at different angles. That's a little bit important. And then you've got your white surface. So for this one, I'm just using a piece of paper to work just fine. And I'm going to turn all my lights on, and they're all a little bit spaced out. And so when they're projected onto the white surface, they're overlapping in a little places, and then they're just kind of their own color in other places. So you're going to hold the lights out at a little bit of a distance, and depending on how big your white surface is, you can kind of move them closer, move them back until you feel like you've got a good amount of color on the wall. And then you take your object, or maybe your person if you're doing this on a wall, and I've got it about halfway between my lights and my wall, so that also you're going to need to play with and maybe see where you get the best shadow. And so when you move your object closer together, you're going to see that your colored shadows appear. And so the one thing that you can look at in my video, I think the order was yellow, blue, pink. And now, because of the order I have these on, my colored shadows are yellow, pink, blue. So that's something you can also play around with, is the order of the shadows, and make some observations about that. But basically, the first part, you want to spend a lot of time really playing with your different variables, which is how far away your lights are, where your object is, and the colors, the shadows that you see. And then, like in my video, I was experimenting a little bit when I brought my object really close, what happens to the overlapping shadows, okay? And if I could see any new colors when some of those shadows started overlapping, okay? So that's the basic setup, and there's a lot you can do with this and adjust depending on your age or how much time you might want to be spending on this. A lot of ways you can experiment and adjust your kind of inquiry part of this, where you basically just get to play around with it and see as much as you can figure out from kind of that playtime. There's a lot of observations you can make just from freely exploring. That's definitely encouraged. So that's the basic setup of the colored shadow. So now we want to understand what's going on, right? It's fun to play. It's totally fun to play, but we also probably have some questions about what's going on. So I'm going to turn my lights off. My kids are going to want to play with them later for sure. And go back to what we've got going on in this experiment. So visible light is a very small part of all of the different wavelengths of energy, essentially, in the atmosphere. So the colors in the middle are what we can actually see, but this is just a small portion of a larger scale called the electromagnetic spectrum. And you might recognize some different waves on here, like X-rays, help us see the bones inside our body. We've also got microwaves that can warm up our food, radio waves to play music in our car. And where the different waves are is dependent on how long the waves are. So radio waves are very long, X-rays are a lot shorter. And then kind of in the middle are those visible lights. So that rainbow, and you'll notice the colors are kind of in order how we traditionally think of a rainbow. So we've got red being the longest of the colored wavelengths, and then green's kind of in the middle, and then blue is on the end. Go back here. So that's kind of important. So there is a reason why the colors of the rainbow are in the order they are, and it's dependent on their wavelength, how long the waves are. So that's kind of the first thing we want to understand is the light waves have interesting characteristics. So they're part of a bigger scale here. We can only see some of these. So the next thing we want to know is, how do we see color, right? These light waves are things that we're seeing in color. So color is based on light waves entering your eye. So for example, this apple here reflects certain wavelengths of color that are not going into the apple. So this particular apple is reflecting green wavelength. And so the green, some of those are going to bounce into your eye if you're close enough to the apple, and they go through a kind of a disc, a clear disc in your eye called the pupil, and the pupil will focus all of those wavelengths to the back of the eyeball in an area called the retina. And the retina has very specialized pieces called rods and cones all along the back of the eye. The rods are kind of picking up mostly like grays and shadows, but the cones are what pick up color. So in this particular case, when the green wavelength is bouncing into my eye onto the retina, the green cones are being activated. And activating that cone is going to send a message through the optic nerve, which is going to your brain, and it's going to tell the brain what you're seeing. So when the green cones are activated, the message to the brain is, you are seeing green. And based on your prior experience, your brain knows that's an apple based on its shape. So white light's a little bit different, and this relates to your explanation last week with the atmospheric optics, and some of the times we can see different rainbows in the sky. Well, you can see a rainbow inside too using a prism. So white light coming from, the lights in the room, if you pass it through a prism, which is kind of this triangular shaped, glass or whatever it's made out of, it'll actually separate out all of the wavelengths of color. So when they're all combined, it looks white. That's how our eye perceives it. But what the prism does is it separates them all out so you can individually see each color. And again, they're in that same order: red, orange, yellow, green, blue, and maybe some purple in there. So white light is a little bit different than the green in the apple. So if there's a white piece of paper, those wavelengths are going to bounce off the paper into your eye, go through the pupil, go to the back of the retina, and instead of just activating one cone, because it was green last time, so we activated green cones, it's actually going to activate all three types of cones equally. And so when they're all activated equally, your brain gets the message that's white. It's all combined together. So our perception of that is white. So what's happening with these different shadows that are different colors is called additive colors. So we started with the three basic colors, and you'll remember looking back here, the cones were red and blue and green, and those are the three colors we used in our experiment as our light source. So red and blue and green are kind of our base colors, but when you combine two or more of them, you end up with new colors. So for example, if I combine red and green, I get a yellow shadow. So if it's in the area where those two overlap, and I put something up in the middle that blocks the blue, you're going to see yellow. Or if the green and blue shadow light sources are pointed and I block the red, I get to see that cyan color. And then if the blue and red are kind of shown and the green is blocked, we get magenta. And one thing really cool to notice, if you ever have to change the ink in your printer, these are the three colors of the ink in your printer. So that works a little bit differently than these additive colors that are using light waves. The pigments that we use in our color printers and what they use to print anything that's printed is actually going to use these three colors down here. So it's almost an opposite effect. So additive colors, it's really fun. Like I said, you can experiment with this for as little or as long as you want, trying to make different colored shadows and combining, overlapping the shadows to see what you get. And you could play around with how far apart your lights are and the angles and things like that. And like I said, really a lot of fun if you get a human experiment going where a person is the experiment and they can move around and play around with the shadows that they create. So I'm going to leave you with kind of a last question as you are exploring your colored shadows. And my question is, how many colored shadows can you make? And you know, you could definitely turn this into, without explaining to your family or your friends, it could seem like a magic trick for sure at first, and then you could wow them with your understanding of what's going on with the colored shadows. So have fun with it. Explore. Science is a lot of fun, and you know, it's always fun learning something new every day. That's my favorite part about science.